Okay, so in this example, or in this problem, we're going to do kind of an introductory example to completing the square. Um, so the way you always begin when you complete the square is you want to get the constant term over to the right side of the equation. And you can see here the constant term is already on the right side, so we're good there. And then we can look at our leading coefficient here is 1, so no problems there. And our coefficient on x, we can always begin by taking 1/2 of that number. Now the coefficient here is -6, but I'll be just fine if I take half of 6 because we're going to end up squaring that number. And so, you know, it's -6, right, but we're going to end up squaring it, which will make it positive anyway. So I take half of 6, which gives me 3, and then what I want to do is square that number. And if I square that number, that gives me 9. Now, keep in mind that what I have here is just some scratch work. I mean, this doesn't really make any logical sense. I just can't suddenly divide something by 2 and then square it. This is just the process that always works for one of your first steps in completing the square. What this does for us is it gives us the number that we're going to add to both sides of the equation. Right? So I take half of this number and I square it, and then I'm going to add that number to both sides. So let's go ahead and do that. Again, this is just kind of some scratch work. So let's come down here a little bit, and I'm going to add nine to both sides. Okay, and then we can do some simplifying. Let's take it one step at a time. The obvious thing over here on the right is that 9 and 2 add up to 11. Whoops. Squared. Okay, and now here's a step that for some reason kind of gets people tripped up, but there's really nothing fancy here. No, we want to end up taking advantage of what we call a perfect square. We want to make this side look like a perfect square. Right? The effect that adding this 9 will always have, or I guess I should say had the effect that it had in this case, is it made this a perfect square. And if you follow this process, you always get a perfect square over on the left-hand side. So when I say you get a perfect square, it means you should end up with some quantity squared, right? It's going to end up being x minus something, x minus a number, right? That's what I mean, quantity squared. That's what I mean by perfect square. But let's go back, and if we ignore this 11 for just a second, let's just ignore the 11, and if we look at this trinomial, we learned a way to factor trinomials in a previous math class, or at least you should have learned that this will factor to x minus 3 times x minus 3, right? So all I did was factor. Now, I'm not solving by factoring, I'm solving by completing the square. So I need to write this as a complete perfect square. In other words, right, x minus 3 multiplied by x minus 3 is x minus 3 squared, and that's a perfect square. And so the thinking here is then that we can undo that square real easily by taking the square root of both sides. Square root of that side, and then the square root of the other side. So we get something that looks like that. And then remember that when you take the square root of a quantity squared, this ends up being an absolute value. And what that boils down to is that we're going to have both a positive and a negative answer. So you always are going to end up writing plus or minus square root of 11. Right, so the idea is that the square root here and the square went away, leaving you with just x minus 3. Right, and when that happens, you get a plus or minus on the other side, a positive and a negative. Right, and then you're just one step away from having the variable isolated. You just have to add 3 to both sides. So when we write this plus or minus, we're really just shorthanding that there were two answers. Right? So if we wanted to write it out the long way, we have 3 minus square root of 11. I need to learn the keyboard shortcut for square root. And then we also have that x is equal to 3 plus square root of 11. Right, so that's the method of completing the square. A couple of things in there that you do need to know from some other algebra class, such as factoring, and that when you take the square root here, you get a plus or minus. But if you're okay with those things, that's a good start for completing the square.